Welcome to Prob Stats 3. So in this video we'll be looking at these things. We'll just we'll just refresh our memory on the formulas. Then we'll just look at two questions and a question and a case study just to solidify our concepts. So let's begin with the first one, like the formulas. So we know intersection. Basically, two events happening together, right? So event A and event B happening together, that is the intersection. If it is an independent event, then the intersection of those two independent events would be nothing but P of A into P of B, right? If it is mutually exclusive events, then A and B will be 0. A intersection B will give us empty set, right? Because when we say two independent events, we are saying something like when we throw a dice and we flip a coin. When we say mutually exclusive events, we are saying, suppose you roll a die, what is the probability that you get both 2 and 3 at the same time? You cannot, right? If you flip a coin, you cannot get head and tail at the same time. So that's what mutually exclusive means. So the probability of both getting a head and a tail at the same time is 0, right? So that's about intersection. Then union. Union is basically rather the event can be either in set A or set B or both, right? So the formula will be A union B, P of A plus P of B minus P of A intersection B. We remove A intersection B because we want to get rid of the double count, right? So again, if it is an independent event, then A intersection B will be 0. And if it's a if it's a exclusive event, mutually or disjoint event, disjoint or mutually exclusive, then A intersection B will be 0. And if it's a independent event, then independent event, then this will simply be minus P of A into P of B, right? So the total formula will be P of A plus P of B minus P of A into P of B. So that's for union. Then complement. Complement is basically what is the probability of a particular event not occurring. So we can write something like if there is an event A, the probability of event A not occurring is P of A dash will be 1 minus P of A. So it is basically all elements of the sample space minus the excluding the elements present in the event. So we can also write this as S minus A. A dash will be S minus A. S is the sample space. Then joint events. Joint events are nothing but you have two events A and B. We are trying to see the possibility of A intersection B. We can do it with Bayes theorem, so many other things, right? We can get it through Bayes theorem, which is P of A given B times P of B. We will see Bayes theorem next anyway. Disjoint or mutually exclusive. We just saw that disjoint events. So if for A intersection B, if they are disjoint, it will never happen, right? For then independent events, we also saw that independent events P of A intersection B, possibility of both of them will be nothing but P of A individual probabilities multiplied. For then we'll look at conditional probability. Conditional probability, what is the probability of A happening given B already occurred, right? So P of A given B occurred, probability of event A given B already occurred is nothing but P of A intersection B by P of B. Then we look at Bayes' theorem, which is just we use multiplication rule in conditional probability to just modify Bayes' theorem. So we say P of A given B, we have our standard conditional probability. So we use multiplication or product rule here, which will give us, so if we take product rule, so suppose here if I multiply P of B on both sides, so P of B into P of A given B will be P of A intersection B. Now P of A intersection B we know is the same as P of B intersection A, right? So we substitute this formula, the outcome in this one, which will then give us, so if we compute P of B intersection A, which is P of B given A, P of B intersection A by P of A. So we multiply P of A on both sides, right? So P of A, that will cancel. So this we plug in the above equation, that will give us P of A given B. We plug this one here, P of B given A times P of A by P of B. That's our base term. So that is a brief refresher of the formulas. Now let's look at a sample question. One second. Yeah, so the question is, in a university 30% of faculty members are females. Of the female faculty members, 60% have a PhD. Of the male faculty members, 40% have PhD. Now the questions are these: what is the probability of a female faculty member given the person is a PhD? Then it's asking the probability of a male faculty male faculty member given it's a PhD. Sorry, it's not given. What is the probability of a female faculty member being a PhD? And the next one is, what is the probability of a male faculty member also being a PhD when chosen randomly? Then the next question is, what is the probability of a randomly chosen person being a PhD faculty member, right? Having a PhD degree. Then the next question is, what is the probability of a female faculty number given that the person is a PhD, has a PhD degree, and same for the male. So these are the questions which we will be answering. We'll be answering this in two ways. One is based on a tree approach, and the other will plug the values into the formula, right? So first we'll do this step by step using a tree and then by the formula. So the first question is probability of a female faculty member being having a PhD degree. So based on the data, what we will do is we will first take a random sample size of 100. So we'll assume the number of faculty members are 100. So total members are 100. So out of these 100, they are saying, as per the question, if you see, 30% of the faculty members are female. So female 30, and of the female faculty 60% have PhD. So 60% of 30 is how much? 60 by 100 into 30, 18. So female given PhD is 18, right? Then of the male faculty members, 40% have a PhD. So if 30 are female, then male are obviously 70 here in as per our sample, right? As per our sample, then they are saying 40% of these male faculty members have a PhD. So male given PhD would be 40 by 100 into 70, that would be 28, right? So 28 of them have PhD degrees in the male category. Now the question is asking what is the probability of a female holding of a randomly chosen person from this sample being a female, and that female has a PhD degree. So we'll use the tree diagram here. So there are 100, and out of this 100 there are 30 female and 70 male, and out of this 30 we have 18 PhD and the rest are non-PhD. So that would be 12 are non-PhD, no PhD. Of these 70, we have 28, right? We calculated here 28 PhD in the male category, and the rest, what are the rest? That would be 42 of them, no PhDs, right? So the question is pretty straightforward. It is saying female and PhD, that would be 18, right? So the probability would be 0.18, right? So this is the question. This is what they are asking. Then so how do we compute this using the formula, right? We'll do this using the formula. So again, for the given data, we already know the data. So P of F is 0.3. P of F P of female given PhD is 0.6, 60%. 0.6. Then we have P of M would automatically be 0.7, then P of M given PhD is 40%, right? So they already gave us, of the male faculty members, 40% have PhD. So probability of the faculty member being a male given they have PhD would be 0.4. Now we just have to drop it into the conditional probability formula, and if necessary we'll use Bayes theorem as well to get the result. So the question is asking P of F. Okay, what the 1 second. Delete. Okay, so the question is asking P of F. Oh god, what is happening? Okay, so P of F intersection PhD. So the question is P of F intersection. Ooh, okay, that thing got switched. Fine. So the question is P of F intersection PhD, right? So we'll use our formula. P of F given PhD is P of F intersection PhD over P of PhD. Now so we already have this value, right? P of F given PhD is 0.6. So 0.6 equals P of F intersection PhD over P of PhD. Now the P of PhD is total PhD holders. We already saw in the previous class, right? This is the marginal probability. We compute this by using law of total probability. Okay, I forgot to add that in the formulas list. So how do we get law of total probability here? So P of PhD, we know, right? Law of total probability, we just use the multiplication rule for every group. So in this case, both male and female we compute. So that will be P of male given PhD. No, that would be, okay, P of PhD. Is it male given PhD or PhD given male? Wait. Of the male faculty members, 40% have PhD. Okay, this should be PhD given male. This should be PhD given female. So the evidence is already that they are females, right? And of the females, the PhD holders are 60%, and of the males, the PhD holders are 40%. So PhD given male times P of male. Then plus we do P of PhD given female times P of female. So we know these values already. We have all the values here, right? This and this. So we simply have to calculate the value. So PhD given male is 0.4. Multiplied by P of male would be 0.7. Plus P of PhD given female would be 0.6. Multiplied by P of F would be 0.3. Now we just have to calculate this. 0.4 times 0.7, 0.28. And this and the bottom will be 6 3 is 18. So 0.28 plus 0.18, that is 0.46. right? So the total PhD holders are 0.46. Oops. Okay. So total PhD holders are 0.46. Let's validate this using our tree approach. So we have 100 of that, there are 30 female and 70 male, and of the 30 female, 18 are PhD in females and 28 are PhD in males. So if we add up these two, 18 plus 28, that would give us what? 20, 30, 46. Right? Seems to be correct. Now, all we have to do is we have to substitute that this 0.46 over here. So we'll multiply and divide PhD on both sides. We'll multiply PhD on both sides. So P of PhD times 0.6, P of F P of F intersection PhD over P of PhD times P of PhD, right? This will cancel, right? So now we have P of F intersection PhD equal to 0.6 into, we'll substitute our total probability, which is this one, 0.46. That is what? 0.46 into 0.6, 0.46 into 0.6, 0.276, right? 276. And is that matching our value here? Wait. Okay. So again, this is a mistake here, right? So we corrected it here, which is PhD given female, but we are calculating this as female intersection PhD. So this should be this should be, let me redo this again. This should be, we should not compute PhD. We don't have to compute PhD actually. The total probability we kind of computed for PhD, but the ask is P of female intersection PhD. This is the same as P of PhD intersection female, right? So we just have to do it for P of PhD intersection female by P of female equal to P of PhD given female. So that's what we know. PhD given female is 0.6. So that was the mistake. So so P of PhD given female is 0.6 times P of female is 0.3. That is 0.18. That's exactly what it is here as well. The tree based approach we saw, where is it? Yeah, there it is. So that will be 18. So that was a slight mistake there. So anyway, I hope it was not too confusing, but we'll do another one with the formula as well. Then we'll just use the tree based approach because that's the easiest one. This one can be slightly time consuming. Let's go for the next question. Question 2, I think this will be slightly clearer. Question 2 is asking probability of male probability of male given, not given, probability of male and that faculty member being a PhD. So when we choose a random person from this group, from this set of faculty members, what is the probability of that random person chosen being a male and that male having a degree, having a PhD degree? So that's the question. So we'll just do it by tree approach. So firstly, let me just copy this one. Okay. That did not copy. Okay. So based on this data, male, there are 70 of them, and being a male and having a PhD is 28 of them. So 0.28 is the answer. So let's do it based on the formula. So the formula P of M is 0.7, P of PhD given male is 0.4. Now right, so of the male faculty members, 40% have PhD. So we know 40% of them have PhD. Now we'll set it in the formula. P of PhD given male equal to P of PhD intersection male over P of male, right? So the question is male intersection PhD, which is same as PhD intersection male, right? Because when you have two sets A and B, the intersection remains the same if it is B and A or A and B. So now all we have to do is plug in the values. So we know this one, which is this 0.4, we'll multiply PM on both sides. That would be 0.7, which is PM. So that is our 0.28. Right, so that's how you solve this. Now the next one is general PhD. We already solved this, right? What is they are asking, if we choose a person randomly in this group, faculty member group, what is the probability that any person we choose, he or she has a PhD. Any random person we choose, they have a PhD degree. So again, like we saw, this is nothing but law of total probability. P of PhD intersection male times P of male plus P of PhD intersection female times P of female. So we just have to, we already did this here, right? We just have to plug in the values, and the result would be 0.46. We can see this by the tree based as well. The number of male PhDs is 28, female is 18. So 18 plus 28, 46. right? That's all there is to it. Then P of female given PhD. Now the question is asking, when we choose a random person from this group, what is the probability that this a person having a PhD is a female person? When we choose a random person and that person is already a PhD, what is the probability that it's a female? So this one again, classic. We can use conditional probability or Bayes theorem, whatever is necessary based on the values we have. So we will do something like P of F given PhD equal to P of F intersection PhD over P of PhD. What values do we have here? Do we have F intersection PhD? Although we did compute it, but looking at the raw values, what are the raw values that we have as per the question? So P of female is 0.3, P of PhD given it's a female is 0.6, P of male is 0.7, and P of PhD given it's a male is 0.4, right? Purely based on these values, what can we do here? We'll have to use Bayes theorem, and we'll use the multiplication rule. I've already explained this multiple times, so I'll just plug in the formula directly. So this will be excuse me, this will be P of PhD given female times P of female over P of PhD. We already computed the total probability above, so we'll just plug the same values. So we know PhD given female 0.6 times P of female is 0.3 over P of PhD is this one, right? This is the total probability, 0.46. That will be 6 3 is 18.18 over 0.46, 0.391. Now let's check it using our tree. What is it saying? The question is female given PhD. So we have PhDs. Okay, I don't think okay, ignore the tree thing. I don't think we can do that way. So this is how you compute this one. You have to do it through formula only, I guess. Don't remember if there is a way using tree approach. Yeah, I don't think so. Anyway, this is the formula way, so we'll do it this way. Same with no wait, female given PhD. So we know all PhDs. What is the probability that it's a female? I think we do 18. Okay. So 18 over 30. No. No, I don't think so. I don't think we can do it this way. Anyway, ignore this. Ignore. Let's go to the next question, which is P of male given PhD. Again, the same. We'll do the exact same things, right? We'll use the Bayes theorem, which is P of male intersection PhD over P of PhD, and this one using multiplication rule, rod rule. I will get my P of PhD given male times P of male by P of PhD. I'll plug in the values. What is PhD given male? 0.4 times 0.7, 7 4 is 28, so that's 0.28 over P of PhD is 0.46, right? 280.46, that is 0.608. That is how you get that value, and that's basically how you solve these conditional probability and Bayes theorem questions. Let's look at now a case study, which is Kerala floods. We'll have to do some data preparation and all that. Okay. We'll be doing this by using the formula as well, and also there's something called a normalized argument parameter in crosstab, which automatically converts, which will automatically give us the probabilities. So rather it will give us the proportions, probabilities. Anyway, that is we'll do that. I believe I have my data. Yes, I have the data. So we'll do the usual ceremony: pip install numpy pandas matplotlib Seaborn. I think I already have all of them, so import np, import pandas spd, then import matplotlib dot pyplot. We'll only be using the pyplot. I don't think I'll be using, I don't think matplotlib is necessary here, but anyway, since I'll be using Seaborn, those are my imports. Now let me load the data frame. df equal to pd dot read csv. The data is kerala.csv. Just so you don't know, Kerala is a state in India. It also anyway, df dot head. Let's look at our data. So these are our columns, subdivision, year, and you have a bunch of months, like all the months, 12 months. And do we have 12 months? 1 2 3 4 5 6 7 8 9 10 11 12. Yeah, we have all 12 months. Annual rainfall and floods. So we are looking at flood data with respect to the rainfall. So if the rainfall is beyond a certain threshold, like how likely it is to flood, etc. And this is based on the month data. Now the question: what is the average rainfall for each month over the years? Right. So average rainfall for each month. So this is simply, we just have to take the mean, right, for each and every column of the months, and we just have to plot that. So let's select our columns. Columns will be df dot columns, and the columns we are interested in is 0 1 2 2 2 0 1 2 3 4 5 6 7 8 9 10 11 12 13. So 13 means 13 plus 1 14, right? These are the columns we need. Wait, COLUMNS. Okay, okay. So these are the columns we need, right? Jan to December. Now, um, we just have to compute the mean for all of this. So, um, so I will iterate on these columns, and no, I don't think I have to iterate. Right? df calls, these are our columns, dot mean. I think this should give us our mean. There it is. So that's how we just do it. So let's call this mdf and reset index. So I'll just make them drop true df. So there you go. There is our, oh no, we should not drop. Wait, we need the column. Okay, we don't drop the column. Now we will set the column names. I'll call the first one as months, and then avgs, averages. So that changes our column names. Now we will plot this. Actually, we can plot it without resetting index as well, but yeah, anyway, that's fine. So we will do right, so SNS dot, use a bar plot. Let's look at the signature ones. Data, obviously the data will pass the data as mdf, and the x-axis x value. Okay, so you see data is data frame series, x is xyr, xyu are names of variables in the data. So we have to pass the names of the variables, which is the month, x is months, and y is avgs. Let's see, and there you go. That's our plot. So from this data, what can we, or rather from this plot, what can we infer? So clearly June, July, August. June and July clearly are the highest, and August is also fairly high, and then September, you see there's a dip, and then October there seems to be slightly higher rain as well. So as per the so clearly these are the monsoon seasons, monsoon months. These are the rainy months. So now what we will do is we'll slightly prepare this data in a way that we can answer the next question. So if you see the next questions, it is asking us to calculate saying calculate the probability of flood given that rainfall in June is greater than the median June rainfall value. Calculate the probability of flood given that rainfall in June is greater than the median June rainfall. So we'll have to somehow distinguish between heavy rainfall and not heavy rainfall, and that we can actually distinguish based on the median. So we'll say if the median rainfall, or rather if the rainfall in that row value is greater than the median of that month, then it's heavy rainfall. If it is less than the median, then we'll consider it as not heavy. So we'll, to just make things simpler, we'll set the heavy rainfall as 1 and not heavy rainfall as 0. So we'll modify our table to make things easier. So let's see now. So we know the months. So from the excuse me. So heavy rainfall months are heavy. Let's call it heavy months. Our heavy months are basically df dot columns. I mean, we can but just do it this. Yeah, I guess maybe putting it explicitly is better. Okay, heavy months are but then I'll have to make sure that the wordings are correct. So we'll do one thing. We'll just get the indices. That'll df dot columns, and we'll choose our columns, which is, so remember df is this one. This is our df, right? Let me just df dot head. This is our data frame. So what we need are June, July, August and October months. So June is 0, 1, 2, 3, 4, 5, 6, 7. So 7, index 7, index 8, index 9 and index 11. Wait, yeah, 7, 8, 9 and 11. So let's see if we have our months. There you go, there are our months. These are the months with heaviest rains. So now now I'll have to get the median rain values for each of these months. So what I can do is, for call in, rather for months in heavy months, I will need to compute the medians. So these are the column names, right? Anyway, so df, I'll add the month name, which is the column name. Okay, wait. Yeah, let's create a map. Thresholds. So I will say 3h thresholds will create a month, and so the way we are making is we'll create a map of month and the threshold value, which is the median, month and median value of the month. So we will pass the month value, and to this map I will append the median, and the median I will get by df month dot median, right? Let's look at our map. There you go, those are our median values, but I don't need float values. Let's keep clean integer values. So don't know, can I cast it as type? Okay. We'll just cast it int. There you go. Those are our clean median values. Now what we have to do is so we have our thresholds. Yeah, now set the, so we'll compare each value of every month with their respective thresholds and mark it as 1 or 0, right? So what we'll do is, let's see, I will take my thresholds for month and threshold in, I'm iterating over this, the items of this map, and I will set the values. So df, I will directly set the values in the data frame. So df month, which is the column names, right? These are the column names. I'm setting the column name, and I'm assigning, oh, okay, we need annual rainfall as well. One second. We need this one as well. So this October is 11th, 12, 13, 14. Okay, 14. Okay, 14. 1 second. This be 14 then? No. Yeah, it is. So we need annual rainfall as well. So we'll have to compute whether this is also beyond the threshold. So we'll have to compute the median for this as well. So let's see, what will this give? So yeah, threshold, we got threshold for this as well. Now what was I saying? Yeah, now I'll compare. So for every month I will compare and I'll reassign. Let's see, df month value, we will check if it is greater than the threshold. And since this is a comparison, it will give us a Boolean value, right? So we'll have to convert it to int just to get us ones or zeros. Now if we look at our data frame, you see here our values got converted to ones and zeros. One meaning it is beyond the median threshold, so it's greater than the median rainfall value. If it is 0, it's less than the median rainfall value. So we have our data ready. Now let's proceed with answering the question. So the question is, calculate the probability of flood given rainfall. So P of flood given rainfall. Oh, that's convenient. Okay. Anyway, given rainfall. Wait, calculate probability of flood given that rainfall in June. Rainfall June is greater than the median June rainfall value. Okay. Given that rainfall in June is greater than median rainfall value. So, what is it saying? Given that June rainfall is greater than median rainfall value, so we'll have to get all the ones here, all the values that are greater than the median. So, June, which is equal to 1. So, flood is true, and rainfall June is 1, which means it's greater than the threshold. Okay, now there are two ways of solving this. We'll directly jump into the creating the cross tab. So we'll do pd dot cross tab. Let's look at the signature once. So it's taking index and columns. We'll set our index as June. Let's keep it June, and columns. So June month 1 or 0 on the, we'll see on the rows side, and on the columns side we will see floods. Columns, floods, and what else? Row names, column names, blah blah blah. We'll set margins. We'll get our totals as well. Margins true. Let's see the using scalar values. You must pass an index. I am passing an index. INDEX COLUMNS. pd dot cross tab. What's the issue? If using all scalar values, you must pass an index. In June is greater than the median June rainfall value, threshold for heavy rainfall. Value error. Wait, margins. Using all, not indices, not raw lengths. Wait, pd dot cross tab. Oh no, wait. What is happening? I have to set indexes series. Oh wait, that is the. Okay, there it is. Okay, so you see these crosstab values are raw values. These are the counts of values where you will see that June month is 0 and the flood values are 42 of them are there. These are the count of rows where these two conditions satisfy. So this is intersection. So now the question is asking, floods are true. So floods, yes. And rainfall June 1, which is 44. So calculate the probability of flood given that rainfall in June is greater than the median. So let's calculate. Okay, so what is it? P of, let me call floods as F. Floods is F, and rainfall June is let's let's call it R. That's fine. So rainfall is R. Now, what is the conditional probability formula? P of F given R is P of F intersection R over P of R, right? Oh, okay. F intersection over P of R. So now how do we check P of F intersection R? If we look at the cross tab, P of floods. F is floods. Yeah, F is floods. F is floods. Floods is yes, and rain, heavy rain, true. So that is 44. So P of F intersection R is 44 over P of rain. So overall rain. So overall rain is 1 second. Do by 118 or so that is the that is all the counts of not less than the median on June. This is greater than median on June, and so total rain. Yeah, so total would be 60. Wait, total would be 60. Total would not be 60. Total would be 118, irrespective of this one. I'm getting confused. Okay. So that would be 44 over 118. That would be 0.372. So this will be 0.372. So this 0.372 is not for F given R. This is for P of F intersection R. So like I said before, these are not probabilities. These are raw values, right? So we have to convert these raw values into probabilities. So P of F intersection R would be again floods yes, and rains greater than the median in June would be 44, and over the total chances, which is 118. So this is for P of F intersection R. Now similarly we have to find the probability for P of R, which is total rains greater than the median in the June month, which would be this one, the total, which is the 60 over 118, because we are trying to find the probability. Now if we compute the conditional probability, which is the question, which is F given R, which is the probability of having floods, of there being floods, given that June month's rain exceeds the median. That would we then compute using based like the conditional probability P of F intersection R by P of R. So we just have to compute these two. 44 out of 118, 0.372, and this one is 60 over 118, that would be 0.50. 508. Now we just have to divide both of them, which is 0.372 over 0.508, which is 0.732. So the probability of floods occurring given heavy rainfall in June, rather rainfall greater than the median in June, is 0.732 or 73%. There's a 73% chance that this can happen given the June rainfall. 73% chance that floods can happen given the June month rainfall exceeded the median value. So that's how you solve this question. Now there is another way of doing it, because right now if you see here, we computed the probabilities, right? There is another way in Crosstab itself which will automatically compute the probabilities and give us a nice contingency table. So for that we just have to set the normalize keyword. So if you see the Crosstab docs, there is a keyword called normalize. So if you see, what it does is by dividing, it's a boolean, it takes all is same as true, and it takes index and column. So what normalize does is it gives us the proportions, percentages. So if we set it by index, we'll get it row wise, and if we set it columns, then we'll get column wise proportions. So like if we set it row wise, we will have something like 30 and 70. Suppose 30 and 70, the total will which will total to 100. In this case, it will be 0.30 and 0.70, which will total to 1, since these are probabilities. And if we set it column wise, we'll have 30 here, 70 here, or 70 there, 30 here, 60, 40, something like that, proportions. And if we set it by all, then it will compute proportions overall, considering overall values. So let's set that here. And also, how do we decide which which column value to set as the normalize pass the which column which column to pass into the normalized parameter? That is based on that's based on the evidence. So here in this case, calculate the probability of flood given the rainfall in June is greater than the median, right? So we set the normalization based on the evidence with here, and the evidence here is given that June is greater than the median June rainfall. So that's our evidence. So in this case, the normalize column will be floods. And the floods is basically the columns, right? Columns. So we set a string. So now if you see, these will total to, the row values will total to 1. No, not by. Yeah, so you see there is a 1. This is already directly giving us the conditional probabilities. So when we set the value to normalize to index, we are getting as per the question P of F given R. So floods yes, right, and given rainfall greater than the median value, which is directly coming to 0.733, which is 73%. So we are directly getting the value, which is 73%, right? So that's how you uh, so that's how we solve this question. So let's look at the next question. um, okay, let me make it bigger. So the question is, given that there is a flooding, so what is it saying? Given there is flooding, P of floods true, calculate the probability that heavy rainfall has occurred in July. So rainfall July heavy is true, is what they are asking us to validate the hypothesis, given floods is true. So we'll use the same thing here, but in this case, the cross step normalization, what do we have to do here? You have to change the index to July, JUL, if I'm not wrong, that is JUL. And the evidence here is floods are true, right? So we'll have to change the index to columns, change the normalization to columns, since the evidence is floods, right? So given that there is flooding, so the evidence is that we already know there is floods. They are saying calculate the probability that heavy rainfalls occur. So we'll directly get the probability. So we'll see, given rainfall July 1. So rainfall July 1 is this thing, and floods is true, which is this. So which is 65%. So there is 65% chance that there is heavy rainfall that happened in July, given that flooding already happened, right? So that's how you do this one. We can validate this using our normal approach. Let's see. So we have our values. So we'll compute the probabilities. Here, the question is P of, what's the question? So yeah, P of rain given flood, right? So how do we do this? P of R intersection F over P of F, right? So let's try to compute P of R intersection F, which is nothing but, if we look at here, rains 1 and intersection floods, yes, that is 39. So 39 over 118. Then we will compute P of F, which is total floods. In this case, total floods will be 60, right? 60 over 118 overall. So let's try to compute this and plug it into our formula over here. Give me a moment. 39 over 118, which is 0.330 over 60 over 118 is 0.508. So that would come to what? 0.330 over 0.508. That came to 0.64, which is close to 65, right? Close to 65, pretty much pretty close. So that is how you calculate 0.649. We could get closer number, but we chose to ignore the rest of the values, right? So that's fine. That is how you get this one. Now let's look at the next question. The final question. What are they asking? Calculate the probability of flood. So we have to calculate flood given that June and July rainfall was greater than their median rainfall value. So both June and July, given June and July greater than median value. So June and July, the values have to be 1. So we can compute crosstab using multiple columns as well. Okay, so let's do the normalization way first, just to get the value quickly, result quickly. Now here we have to choose both June and July. So if you see the documentation, the index accepts. What does index accept? Array like series or list of arrays or series. So it can accept multiple columns, right? So I will pass June and TF July, and the my columns will be floods, and I want to normalize by the evidence. What is the evidence here? The evidence is the rainfall, which is our index this time, right? And that is how we get the crosstab. And based on the question, floods is true, so there is floods, and June and July both have to be 1. So we have June 1 and July 1, which is this value. So there is 90% chance, 0.900 or 90%. So there is 90% chance that there will be flood given if the June and July rainfall value is greater than the median value. So that is how we do this one. Now let's do it the normal way without the normalization. So let's see the values. Okay, what is the question? Question is P of F given rain, right? Our standard this one. So P of F intersection R over P of R. So let's calculate P of F intersection R. In this case, P of F intersection R would be floods, yes, and rains, both true. So meaning both greater than the median. So that would be 27 over total is 118, right? Total is 118. Then we'll calculate P of R, which is total rain. So total rain, all greater than the median value, is 30 over 118, right? Let's compute the values. 27 over 118, which is 0.2288, and 30 over 118, which is 0.254. So now we will 0.2288 over 0.254, which is, as you can see, clearly 90. 0.900, which is nothing but our 90%, right? And so that's how we solve these questions. I hope that was clear. And yes, I'll see you in the next one.